Today we have kind of a shorter lesson, which I'm sure you'll be really upset about, but that's okay. We're talking today about an inscribed polygon. Basically, an inscribed polygon is a polygon that has every vertex on a circle surrounding it. You can see that in the picture here. I've got my polygon and my circle going around the outside, okay? That polygon is inscribed in the circle, or we could say the circle is circumscribed around the polygon. So inscribed, circumscribed, they work together. Now, so if something's inscribed, it means that the important points are right on the circle. So let's talk about inscribed right triangles. We got a couple special situations here with inscribed polygons. First off, if I inscribe a right triangle, so ABC is a right angle, okay? If I do that, well, then it says the hypotenuse must be a diameter of the circle. Well, why is that so? Why is that the case? Well, let's think about this for a second. If this is an inscribed angle, angle ABC here, and it's 90 degrees, I know the measure of the arc that it's intercepting has to be twice as much as the angle. So that arc must be 180 degrees, which means that's 90 degrees. But 180 degrees means that's at exactly a semicircle, isn't it? Which means that the endpoints here must form a diameter of the circle. So one way to find a diameter of a circle is to inscribe a right angle in the circle. And any angle, conversely, any angle inscribed in a semicircle is a right angle. So if I know this is a diameter, I know this is an inscribed angle, it doesn't matter where the vertex, where BFB is here, anywhere along the edge here, it must be a 90-degree angle because it's intercepting a 180-degree arc. Inscribed quadrilateral theorem, that's our other one here. The inscribed quadrilateral says quadrilateral can be inscribed in a semicircle if and only if its opposite angles are supplementary. Now this is a little bit more subtle. So let's take a look at this in a little more detail. Okay? So let's say I'm going to give myself a radius. Again, this is the best way to draw a circle on the smartboard. First we draw the radius, then we use the tool to draw the circle, otherwise the center of the circle disappears. Okay? So I've got my circle center right here. I'm going to mark that. All right, so now the radius doesn't really matter much anymore. So I'm going to go ahead and inscribe a quadrilateral. So I'm going to go ahead and we got that segment, and let's do another segment from here to here. I'm making sure this isn't any special sort of quadrilateral. It's just some random quadrilateral, okay? It's not a trapezoid, it's not a parallelogram, it's nothing in particular, just some random quadrilateral. Now, I said the opposite angles have to be supplementary. What does that mean? Well, it means the opposite angles have to add up to 180. Why is that the case? Well, let's take a look at one angle. We can pick any of my one angles here. I'm going to call these points A, B, C, and D. So let's start with C. Well, if I look at angle C here, I kind of outline angle C. All right? Here's angle C. And angle C intercepts an arc from A to B. That's fine. I don't know the measure of angle C. I don't know the measure of that arc. I don't know either one, but I know that's what angle C intercepts. If I look at the opposite angle, angle A, and I look at what arc that intercepts, again, I don't know the measure of angle A. I don't know the measure of arc BCD, which is obviously in this case a major arc. It's more than half the circle. But I know the arc is twice as much as the angle. But what do you notice about when I put the two arcs together? When I put these two arcs together, the purple arc and the green arc, okay, so the measure of arc, if I call this arc 1 and this arc 2, the measure of arc 1 plus the measure of arc 2 equals 360, doesn't it? It's the whole circle. Which means that the sum of the angles, because the angles are half the measures of the arcs, the measure of angle A in this case plus the measure of angle C has to be half, 180. Has to be supplementary. And I could do the same thing with B and D. If I showed where their intercepted arcs were, we'd see that the arcs add up to the whole circle, which means the opposite angles must add up to 180. So an inscribed, so a polygon can only be inscribed in a circle, or quadrilateral can only be inscribed in a circle if the opposite angles are supplementary, which means most parallelograms won't go in unless they're rectangles or squares. Okay? Let's use this. Let's use these theorems. First one, I know since AB is a diameter of the circle, that this angle is intercepting this arc. This arc is exactly 180 because it's half a circle, so 2x has to be 90, so x has to be 45. That uses semicircle portion. Here I'm going to find y and z. Now, I'm going to go ahead and let you work on those for both y and z. That goes exactly back to what we just did here. Opposite angles have to add up to 180. See if you can figure out what those angles are going to be. Here's an application. It says your camera has a 90-degree field of vision, and you want to photograph the front of a statue. It looks like the Statue of Liberty. You stand at a location which is in front of the statue is all that appears in your camera's field of vision, as shown. You want to change your location. Where else can you stand so that the front of the statue is all that appears in your camera's field of vision? Okay? Kind of an interesting question. How can we move? But the basic idea is this, is that this, since it's a right angle and we go to the endpoints here, the center of this side represents the center of a circle. And if I draw a circle here, and we're going to be close, not a bad little estimate, but off just a little. Move that around. Whoops. Undo. Wrong tool. There we go. Okay. So there's my circle. And what I can see is that any line there along that, any point from here to here to here, I'm still going to get the same endpoints. Even if I move my angle here, this is still going to be a right angle because any angle inscribed in a semicircle is a right angle. So I can move anywhere on this arc and still get that 90-degree field of vision for my statue. Okay? So kind of a thought problem there, a little bit different. And back to the more practical problems. How do I solve the unknown sides and unknown angles? This is more of like what you're going to see in the homework. So again, L is inscribed in a semicircle. This arc is 180, so this X must be 90. Now I've got 90 and 40 in that triangle, so 180 minus the 90 minus the 40 equals Y, so Y is going to be 50. For 5, my opposite angles have to be supplementary. So X plus 82 has to equal 180, and Y plus 68 has to equal 180. So X equals 98, and Y equals 180 minus 68, which is 120, 112. Pretty straightforward. Now you do it. I'll do X for you, you do C. So 10X plus 8X has to equal 180. So 18X is 180. So X is 10. Now you find C. And that ends our podcast for today.